If you would please just tell us your name, your affiliation, and if you took an SSI class, which one you took. If not, that's okay.
So my name is Nicholas. I actually work for Richard, so that's my affiliation. And taking the HLM class. Yeah, I wanted to ask you, someone once said that if you torture the data enough, it will confess to anything. So I was wondering if you could share a funny or interesting experience where you actually got more out of the data than you should have, and what happened, and how did you fix that? And then finally, maybe you could also share with us what kind of tools you use for data analysis.
Who would like to go first?
I can start, but I'm not sure that I can actually answer the torturing of data question. Typically, we have such a volume of data that any one particular piece doesn't get analyzed to death. We do have lots and lots of data, and occasionally we'll get errant correlations out of that from the models that we have, and Richard spoke to that a little bit as well. But as far as tool sets, we're all very creative people, I'm going to say, sitting at this table, and we'll tend to use whatever tool we can get our hands on. So the teams that I've managed and what I've done will use R for a statistical package quite often. We'll do a lot of Perl. And when the MapReduce type of analysis is a little bit bigger than you can sit comfortably in Perl's memory footprint, we'll switch over to Java. A lot of times, actually, I think we're starting in Java now because our data didn't used to be quite so large, which was mentioned earlier as well. But it's going to be programming languages and statistical languages for crunching the data, for pulling it out, lots of SQL to deal with the various databases that we cram it all into. And for my own industry, we use a lot of intranet presentations, so all of our delivery mechanism is through HTML, JavaScript, HTML5 type of applications.
Thank you, Steve. Anyone else?
Yeah, as far as the data torture, I'm sure we've done that. I can't think of a specific example, but you're right. I mean, you can torture it to death and basically start to get the statistics to point to almost anything you want to if you try hard enough. So it is being able to really look at what's the business problem or the business issue, and does the data support it or not in its appropriate form. We use a lot of Cassandra databases, Hadoop, those sorts of things. So we use Mahout and other type tools. The problem we find is a lot of the tools that currently exist don't have what we need. So we either write a lot of it ourselves or extend existing open source things that are out there. So, and then you'll see, I think we put a lot of stuff into the open source community around this as a result.
Yeah, I think for us, one of the most dangerous territories, and this has come up a couple times before, is the conflation of correlation and causality. And to a certain extent, the reason that we're kind of creating front-end applications on top of the work we're doing is to help to answer or solve that problem, such that we may find lots and lots of things that are pretty well and strongly correlated in a database going backwards, but often the data that we get tends to be proxy for other data and other factors underneath it. And so understanding that data that's correlated on the surface may actually not be remotely causally related, and trying to build recommendation engines that start to tease those things apart from one another with sort of rigorously designed experiment and control implementation of those recommendations is a big part of the work we do to try to avoid data torture. But it's definitely the area of work that we're in is a minefield for that kind of challenge, I think, often because this data has not been used for these purposes before. I can tell you just one example of a sort of simplistic approach that turned out to not be ideal. We've taken large data snapshots, historical data snapshots from all the institutions that we work with. So in some cases, we literally have data that goes back 40 years. Students that the institution's been serving over the course of 40 years. And you can split your test and training sets, obviously, across a variety of different axes. And so as we took a first cut at this, we said, isn't this fantastic? We've got decades, literally, of data, lots and lots of data to build these models. We're generally trying to use as much data as we have to sort of predict what's going to happen next. That's the heart of what we're doing. So if you took the not even 40 years, 30 or 40 terms of data to try to build a model that then predicted the 41st term, students' performance in the 41st term, we found that our predictions weren't nearly as strong as we had expected them to be. And when we mapped out the accuracy of the predictions across that period of time, so the split of training and test, the accuracy of the prediction, actually the prediction was sort of, it was over predicting student performance early in that period and then under predicting towards the end. So what we realized is there were lots of dynamic changes through that period of time. The institution actually got better at serving students. And so we found we got a dramatically more accurate presentation by, or prediction by cutting down to just 5 terms of data to predict the 6th, and went through a whole iteration process and model competition to figure out what is that sort of ideal epoch of data that actually is going to sort of capture whatever recent changes have been made to the institution kind of more effectively. So I'm not sure that qualifies as data torture, other than the sticking to the mantra that more is always better. Turns out, of course, that's not nearly the case.
Yeah, I guess and again, I don't know if data torture, but I know one of the things that is a challenge is always that, well, what about, that question that we get. And one of the things that we have to always be mindful of is that our cell size doesn't get so small that we actually have like one representative in the cell that then generalizes to a population of 20,000. So that's where we've got to be very careful with our data. And the primary tools we use are SAS, SPSS, and JUMP.